I'm going to go ahead and share my screen now, and everybody should be able to see that. And I'm going to go ahead and start with showing you a quote. So, this is a quote that we got for the production of a part made in Mexico. And what you'll see as I scroll through this here is it has quite a bit of detail on it. Which may or may not be what you typically get from your suppliers. I think that that's okay. I'll talk about how you can use the tools to kind of work backwards into what some of these numbers might be when you look at it. But the sort of thrust of this presentation is going to be around the quote for this part. We're going to develop a should cost for this part, and then we're going to look at the differences between them. I'm going to be using our upcoming DFMA 26A should costing software. So you'll see some new things that are in that I'll point out as we go through it. But I sort of want to let the audience know that this is a pre-release of that. It's features that are going to be upcoming that you'll be getting if you're under maintenance with us or if you have an active subscription with us currently. So here's this quotation. It's for a cast handle. It's a die casting made out of A356 aluminum. It's anodized, and you can see here some sort of general information. And then the supplier has given us a summary of the price. So it's $1.89 delivered here to East Greenwich. And including the cost of the tooling, we're at $2.22 for the cost of the part. And then the supplier, in this case, gave us lots of information about each of the breakdowns. So this is really what you would call a good open book quote for a supplier that we have a good relationship with. So you can see here some information about the price of the material, the usage of the material, what the material cost per part is coming out to. Here they're telling us they're going to make this on a 2-cavity die with a 300-ton cold chamber die casting machine. They've got cycle time information. They've got rate information for the machine that's rolling up a casting piece part cost here for us. We've got information about the trimming operation. We've got information about some secondary machining that's going to take place on this part. They've given us a cycle time with a machine rate, and that's giving us a machining cost. We're anodizing this part, and you'll see when I show it to you here in a second, there's a couple of holes in it that we're going to mask before we anodize them because we don't want the anodizing material to be in the holes. So there's a masking and anodizing. There's a final inspection operation. And then they've got the sort of summary of the rolled up costs. They're including some SG&A and some profit margins to get to their $1.68. And then we have a breakdown here of the tooling schedule. And then there's some technical stuff about, all their sort of terms and conditions and notes and things. So a very detailed quote that we're able to work with here around what it should cost to manufacture this part. So what I want to do is walk you through now how we would do a cost analysis of this piece so that we can start to dig into the details and find out whether or not this $2.22 looks like a reasonable price for us to be paying for this part. And maybe we're undertaking this exercise because we thought that this seemed high relative to what we were expecting to see as a quote, or maybe we've done a Pareto of all the parts in our products, and this is one of the parts that's a big portion of the spend on a simple product that we're making, or something like that. So this is our 26A. You'll see here software dashboard, and I'm going to run the new DFM should costing tool, DFMA should costing tool, and I'm going to import a CAD model of this part that we're going to work with. So I'm going to import it here, this casting with finished machining. It's a little die cast handle you'll see here in a second when it comes up on the screen, and it mounts to a cover that we put the screws through those holes there that we're going to mask, and we can pull it off. So it's die cast, and Y is the forming direction. So here I'm going to choose Y as the forming direction. I've got 100,000 parts as my default choice. and I'm going to select a process and a material. So here I see our manufacturing process dialog box. On the left-hand side, I'm going to choose cold chamber die casting. And you're going to notice something different right away in the 26A release that's upcoming. We have now come up with a method of categorizing the different global costing data regions. So what'll happen when you install this is the updated 26A cost information will be put here at the top. The 26B profiles that you had are put in a category down here at the bottom. And then any profiles that you've created yourself, there'll be a My Profiles category, and those profiles will be put into that category. In the profile description dialog or the profile definition dialog, you can edit this and make your own tree nodes and move things in and out of them if you want to make it easy for you to use. Another big update that is in this 26A data set is we have come up with subregions of the United States. So if you're not subscribed to the data or you don't want to get into that level of detail, you'll have this 26A United States profile, but also we've split the United States into 15 different regions now where you can look at the manufacturing costs in each of those different regions of the US if you want to. So there's some additional data sets being added in addition to the existing manufacturing profiles being updated with all the information that's in the libraries. So we know this is being made in Mexico, so we're going to choose the Mexico profile, and then it was A356 aluminum. So I'm going to make those choices. And then I'm going to say, okay, now the other thing, I have my software set so that our dynamic cost agent is turned on by default. And so you're probably going to see little information on the screen here when I say okay. You can turn that on by default yourself. I'll show you how to do it here in a second. And when I say okay, you'll see the software gives me a cost and it shows me only these inputs for the die casting because, like I said, by default, my dynamic cost agent is turned on. If you go to the analysis menu and you choose set units, and then here you can see that you can change this from off to on if you want your dynamic cost agent to be off or on for when you do new analyses. And so what that does is if I turn it off, that shows me all of the inputs that would be important in understanding the cost of any die casting. If I turn it on, we do a sort of sensitivity analysis. It's a dynamic sensitivity analysis in a sense, where we go through and we look at all of those inputs and we decide whether or not they would be material in the piece part cost result for this given specific die casting that I'm trying to look at. So these now become the inputs that are important to this die casting, not the inputs that are important to any die casting. And you can see it greatly simplifies the number of inputs. In fact, the only thing that it's saying matter here are the plant efficiency, the cost of the raw material, the volume of the part has come from the CAD models, and we're using the density then to back calculate the weight, and then any actions that might be in the tool. Those are the things that are going to influence the cost of this particular die casting in a material way. And as a result of that, we've come up with a piece part cost. Now that has caused the software to select a 200-ton die casting machine, and it's optimized based on the number of the complexity of this part, the number of surfaces on it, and using a 4-cavity tool to make this part. That die casting machine has a rate of $38.92 an hour. And then we can see down here some details of the die casting operation and the trimming operation if we wanted to investigate that a little bit further. Now, there's some secondary operations that need to be added here. So I can choose this insert operation choice. And we know we want to, well, first, actually, sorry, I need to machine it. And I didn't mention this when we looked at it, but these two surfaces here on the part need to be flat so that when I mount it up with the the cover that I'm mounting this to, that it sits flush and there isn't any unnecessary load put on the handle by tightening down the screws with an uneven surface there. So what I'm going to do is I'm going to insert our dynamic cost agent for machining. And again, this greatly simplifies the process. So I choose this option to add that. You'll see it puts it on there for me as a line item. And I simply tell it I have two finished planar machine surfaces and no secondary holes that I'm drilling in this. And then again, it does its analysis where it shows me the only thing that's important is the average diameter of the milling cutter and the finished area that I want to machine. And that has a little calculator next to it where I can bring in the CAD model to actually identify what it is that I want to machine here. So I'm going to select these two surfaces, and you can see it's 1.563 square inches of area that I want to machine. And when I say OK, it fills that in for me here as the input, and that calculates then a machining cost for that secondary operation. So now I have a die casting with machining, and I can add my post-processing operations, if you will. I want to do a masking operation here, and then I want to do an anodizing operation. Now, I would flex off these a little bit if I wanted to. Maybe I'm going to mask this with plugs, and I would, I can edit any of these inputs here that I want to. If I wanted to change that, I could look at the code in the operations library and edit that. Here's the information about my anodizing operation. I can click calculate and see the results of where that anodized cost is coming out. And then up here at the top, again, I can insert, if I want to, adding profit, SG&A, shipping, and even tariff costs to the result of this analysis. And so we could go through that and finish it. I'm going to open up a finished one here for you in a second. But I want to show you, before I get too much further into this, one final, I think, pretty powerful, nice addition that we've come up with the 26A release is we're calling it the multi-region analyzer. And so when I click this button, what we're going to get is a window. And here this window shows me all of the analysis tabs that are in this file. So if I had several of them already, I'd have several lists here. And you can see it's telling me it's a cast handle with finished machining, cold chamber die casting was the process, and 26A BDI Mexico was the library. Well, if I select that and I want to see the cost of that in different regions now, I can just choose them over here on the left. So if I wanted to see what this part cost in, let's just say China, India, and Vietnam, I can select those three, say OK, and the software will actually make the copies of those analyses for me and give me the analysis tab results here. And you can see it appends them with China, India, and Vietnam coming from the Mexico profile. And I have the results now finished of that part being made in each of those different regions. And then, of course, I can use all of the cost analysis graphs and reports that we have in here to arrive at the results. So there's the cost in Mexico, China, India, and Vietnam played out across those different scenarios with the different cost data sets showing me the results. So we've tried to make it easier. Instead of having you copy and paste it each time and select the process and a material, you can simply select the analysis you want, select the new profiles you want, say OK, and all of the costs will be calculated for you as a result of that. So let me close this now and not save it. And I'm going to open up the finished one. This is just one that I've saved and put all the data in. You can see here I added the profit, SG&A, shipping, and tariff costs that were cited on the supplier's quote. And where that brings me is to a cost of, if I include tooling, $1.16, it's $1.03. If I include profit and SG&A, it's 85 cents or something like that if I don't include those. So I have now a cost analysis that I've done independently based on the science of the manufacturing process. And I'm seeing a difference between the detailed breakdown of of cost in that quote. And so the question is now, let's dig into the details and try and see where those differences are. And I think that's an important thing to try and look at is, how do we turn the information that's in this supplier bid into something that we can use as part of our cost analysis, but we can also use to negotiate with them based on the data, not based on simply an argument around what their quoted price is. And so, kind of taking a step back just to kind of refresh where we are. We've got this cast handle made out of that material, the sort of information over there on the left. And we've got a supplier quote that's in an open book format, and we've done a should cost analysis with our 26A Mexico profile. The result of that is this, that supplier quoted us $2.22. We came up with $1.16, right? The 85 cents before we added in the profit and the tariff and the duty and all that stuff to get us to the $1.16. And so our price gap there is $1.05. Now, I think it's important at this point for me to say that's not what you should expect to pay. That's not what you're going to save. That's just the difference, right? I mean, you might, but I think it's reasonable to expect that you might get a portion of that $1.05 as savings. But let's dig in now to where that is. And I suppose, it's worth mentioning here. We can look at that over the 100,000 parts is $105,000 of potential cost savings for this piece. And over a 3-year program life, we're looking at north of $300,000 of savings if we were to get everything that we're going to walk through here. So here's the quote from the supplier with, their quote and their breakdown of where their piece part cost is coming from. And here is the breakdown of our cost analysis, and then a breakdown of the material setup, process reject, and tooling costs that we're seeing. And then here's a line by line of where the dollars are actually, I said hiding, but where are they different? And so here we see some cost discrepancy between what we're being quoted and what we've come up with as a cost estimate based on the input price of the material. So this is our BDI Mexico profile with its default number compared to what the supplier is quoting us. There's a 9-cent difference. We're seeing about a 22-cent difference in the casting process. We're going to get into where that lies in a second. Some cost difference in the trim die, the machining, the masking operation, the anodizing operation, and then they included a nickel for quality and inspection. And you can see I neglected to include that in my cost analysis. So if I were to put in an inspection step, then I'd expect it to add some cost back in to show me what that cost difference would be. And so all in, you can see the cost total differences there showing annually what the potential cost savings would be if we were to reconcile the differences in each of those categories. So this is kind of a big one. And what we see here is the supplier quoted as a 300-ton die casting machine with a 2-cavity die and a 30-second cycle. Now, our DFMA should costing tool uses a first principles approach to should costing. We are looking at the underlying science of the die casting process to calculate all of these details. And our analysis showed that we should use a 200-ton press and a 4-cavity die, and we actually calculated a cycle time of 25.3 seconds. So there's at least a discussion that needs to go on here. Why are they telling us they need to use a 300-ton machine for a 2-cavity die? Is a 4-cavity die realistic? Why are they quoting a 30-second cycle? I mean, I think we all see this all the time, right? The cycle times are always these nice round numbers. Is there just a little bit of extra money being made there as a result of that? Or do they actually have a time study that shows us that that's going to be a 30-second cycle? Now, if I just flip back to the software for a second here, this is kind of a nice feature that's in here. If I go to the die casting process and I run this process simulation, you can see here what it's showing me is the cavity pressure and temperatures that would be required for this casting analysis. But this is an important one. This is the calculation of the required clamp force based on the 4-cavity tool. So we're not making this up. It's again based on the science of the manufacturing process. 129.18 tons is the required clamp force. So the 200-ton die casting machine is the cost-effective choice that's physically capable of making this part. And so we have to then ask ourselves, is it because this supplier doesn't have a 300-ton die casting machine? Sorry, a 200-ton. They only have a three, or maybe they're 200 tons busy making parts for other people. That's fine, but we shouldn't be paying for that extra capacity. And we only really find that out by having, again, this discussion about the details with the supplier and the information they've supplied in their quote versus our first principles approach to understanding what the manufacturing cost should be. So where else is the money in this? Sort of other cost levers, if you will. Well, we've got about $20,000 difference in our estimated cost of tooling. So what would we ask the supplier? Well, could you rebid this with a tier two die shop maybe in Mexico? We've got a difference in machining. 58-second cycle seems like kind of a long time to finish machine 1.56 square inches of material. Could we see some information about where that's coming from? We've got a $9,000 difference in the cost of material. That's based on the difference between the supplier's quoted price and again, our assumed cost for the Mexico manufacturing profile. And then if you were to dig into the details of it, the supplier here has actually said they're going to outsource that anodizing because they don't have internal anodizing capability. And so that's why their price of 18 cents is high. And so then it would be a question for us of, do we want to pay that and just have them supply us with the anodized part? Do we want to find a supplier that has in-house anodizing, or do we want to look to do it somewhere else, some other way? So what's the playbook then? Well, certainly this discrepancy between machine size is something we want to look at. Certainly the difference in tooling is something we need to understand and investigate. Again, like I mentioned, the anodizing, the machining cycle time, and the difference in the material cost. So all of that is going to let us understand maybe the opportunity to come up with about $125,000 worth of savings over the life of this program. Now let's sort of extend this thinking outward. I think this is worth taking a second for. We're talking about here one part. And so, think to yourself, what does your actual spend look like? It could be that, we're saying here for a typical Fortune 500 company, you've literally got hundreds, even thousands of these parts that you could do this kind of analysis on. And you're looking probably at tens of millions of dollars at a minimum of direct spend and thousands of supplier quotes that you're looking at each year. So you could potentially, Pareto this in some way where you can start to look at where is your spend and focus in on the parts that you want to do this work on and uncover really big opportunities for savings if you think outside the single part example that I've been giving you here, So just to put some kind of numbers on it, we've introduced an ROI calculator now on our website. It's really useful. I think it's worth taking a look at to help you understand what some of these numbers might look like for you. But if you're spending 50 million a year and you look at just your top 100 parts, assuming a 30% gap and that you would only capture 15% of that 30% gap, you're looking at a 1-year run rate on savings of about $5.25 million as a result of taking the time to do this kind of analysis. So I think it's valuable to think kind of at that macro level sometimes. And, when we get bogged down in all the details of cycle time calculations and machine size selections, let's think big picture about why we're doing these exercises in the first place. And so, you got to ask yourself these questions about whether these paybacks are worth the investment that you're making on the cost of the software, but also the resources internal to your organizations to do this kind of work to achieve these kinds of savings. So how do you know it's right? And that's a question we get asked all the time. And so I think what you could see from the results of that analysis is there's not a tremendous amount of information required from the user to get a result. We're providing you with the machine rates, the operator rates, the material costs. with the dynamic cost agent, we're providing you with all of the inputs that matter. So all I had to do was decide whether or not I wanted to edit the material cost and define what the finished machine surface area was going to be. So this process-based first principles approach to understanding the cost is truly working for you with our regional cost data, the automatic machine selection, to get you almost all of the information you would need to come up with a good cost estimate for the production of the part. So you should feel confident using these tools that you have the ability to push back on the supplier around some of these details that you're seeing. How do you deploy this? Well, how do you implement it and do it with every quote? Well, certainly you need the tools. You need to do some training so that people know what they're doing. We've got online resources. We can do online training for you. You need to somehow prioritize what the parts are that you want to be looking at. So some Pareto of your spend or something like that to kind of narrow down the list. And then it's this detailed analysis of the part and investigation of the quote to reconcile those differences to drive the savings results that you're seeing. And so on one part, we're looking for the potential here of $300,000 of cost savings. Think about the impact of this to your business if you were able to achieve these kinds of things with the bulk of your spend on your however many hundreds, tens, or hundreds of millions of dollars of spend you have across your organization and in your programs. So I also highlighted for you there a couple of things that are coming up in the DFMA 2026A release. I hope that you'll find those to be useful. I know that you'll find the detailed data to be useful. I also have here, I'm going to paste it into the chat, a link where there's a more detailed discussion here in this PDF of what each of the differences in cost between the supplier quote and the cost estimate that we came up with were. So feel free to click on that link and save that PDF if you want to, and go through it and answer any other questions that you might have, or ask any other questions that you might have. You could certainly reach out to us and let us know what those questions are, and we'd be happy to get back to you. So thank you very much for all of your time. I appreciate you listening. Hopefully we've given you a little insight into a way to use these tools, little insight into what's coming in a future release. And we look forward to continuing to help you succeed and to working with you to achieve your goals. Thank you very much. Bye-bye.